If your mind was just totally blown by the previous explanation of how to make equations out of data sets, then we don't have to necessarily do it by hand. I mean, this just goes up by 2 each time, so the slope is 2. But we can also use a calculator to get a lot of that done for us. So the place to do that is under the way to model data using the calculator is using this statistic button right here. So I'm going to click Stat. And then I can put the data of any one of these 3 data tables in. In this case, I put the data in for the first data table. -2, -1, 0, 1, and 2, and so on. And the calculator can model it as one of these 2 things. So the 3 options are here. Option number 4, if you think it's a straight line. If you think you're dealing with a quadratic, you're going to try option number 5. And if you think you're dealing with an exponential, you do all the way down to option number 0, EXP, exponential. So what if we were to do the wrong thing? So what if I were to model this as an exponential? I know this data is linear here, but what if I try to do it as an exponential? You can see that I would get something that doesn't make a whole lot of sense. So these aren't nice solid round numbers. It's possible that the problem that you got wanted these numbers, but the most likely thing in a textbook is nice, easy numbers. So I'm going to do it not as an exponential function, that's the one I just did, option 0. I'm going to do it as a linear function, option number 1, or option number 4. And you can tell that's a straight line because it's in our famous equation ax plus b. Instead of mx plus b, they're using the letter a, but that's the form of a line. So I'm going to calculate it as a linear regression, and you can see that the calculator is telling us exactly what we needed to know. It's telling us that a, the letter in front of the x, is 2, and b, the number that's over here by itself, plus b, is 11. So this is telling us that the way to model this is 2 times x plus 11. And I'll be right back with this next one. So as you can see, I've pushed stats and I pushed edits, and I put the new numbers in for this middle one, 1.5, 3, 6, all of them went in here. And I'm going to push again to calculate. I'm going to go to stat again, and I'm going to calculate one of the regressions, or I'm going to turn this data into an equation using the parent function that I think it is. Now, I know that I thought this was an exponential function, so the correct option is here, option number 0. But what would happen if you did it as something that was not the correct option? So you can use this to decide what kind of function it is. So what if I modeled this exponential function as a straight line? Well, I would get okay results at 5.4 x plus 9.3, but I'm probably looking for nice solid numbers in this problem. The correct way of doing it is an exponential function, which is here, option number 0. If I were to make that calculation, I would get a parent function, y equals a times b to the x, where a is 6, 6 goes here, and b is 2. Sorry, folks, this should have been a 2 here instead of a b. All right, third one. I have modeled my final data table, and it is 82028, which I know is quadratic because it changes direction. It goes down from 8 to 0 and then back up again. And I'm going to go back to calc. I've got 3 options, either option 4 for a straight line, option 5 for a quadratic, or option 0 for an exponential. If I pick option 5 for the quadratic, it's going to give me a slightly more complicated parent function. It's possible not just to have ax squared and plus b, but also ax squared plus bx plus c. There could be a middle term in the trinomial. And we don't have the middle term here. Why? You can tell because b is 0. b is 0, so that's 0x. We don't have that term. And c is 0. We also don't have that term. A is 2, however. 2x squared is the function, 2x squared. If I were to try to model that incorrectly as a straight line, say, then it would give me something that didn't make any sense. 0 and 4, what it's saying is that this is symmetric, so it's going to go this way. It has a slope of 0. And then if I were to model that as an exponential, it certainly is not an exponential. It's going to give me this domain error. Okay.